Hello, welcome to my presentation. We will cover post-quantum cryptography in OpenSSL Library and why we added that and what you can do with that. So, perfect. So, what we will cover? I will tell you something about me. If you don't know me, most probably you met me on our booth. So, what we added in OpenSSL 3.5, which was released 8th of April this year. And we will cover post-quantum cryptography part in OpenSSL Library. So things like what we added, why we added that, and some hands-on. So I am engineering manager in OpenSSL. I worked there for 2 years, 2.5 years. Before I was working 16 hours in telco and before in other small companies. I am Eagle Peacock, because we do personality profiles, and this is one, if you are interested, TIC.com.au, which represents me that I like nice things and I like tasks done. What I do in OpenSSL, I'm trying to change development into agile development, which is really challenging, because if you imagine corporation where you own resources, means own engineers, and you can tell them what they will do, it's easy. But I'm not in that case because we have so many incoming PRs and developments that I can't really control what happened when. So it's fun. If you want to connect with me on LinkedIn, here is QR code. Okay, well, someone is taking a picture. Perfect. So what we added? We added support for Quick Server, RFC 9000. It's, maybe you know that we have OpenSSL TLS server or S server. This is not that one. We added support from API point of view. So you can build application with Quick Server on top of OpenSSL. We added third-party quick stacks, support for third-party quick stacks. That is, again, something maybe you will not use, but it is used in many currently free quick stacks, and there are not many others. The covered support for OpenSSL is MS Quick, so Microsoft has that, Nginx, and soon we'll have Quiche from Cloudflare. We added support for quick post-quantum algorithms, so MLChem, MLDSA, SLHDSA, we will cover in the rest of the presentation. We added FIPS provider. We added, or let's say, we allowed FIPS provider to use jitter seed source. We added support for central key generation in CMP. We added, thanks to Red Hat, support for opaque symmetric key objects, which is EVP key in our API. And we added support for multiple TLS key shares, which means that your TLS connection can easily negotiate the key share which will be used. So maybe you don't know what is a post-quantum algorithms. Post-quantum algorithms and cryptography is that we try to use algorithms which were developed somewhere in universities and by other parties, which are quantum computer safe. And you may know it that is quantum proof, quantum safe, quantum resistant, and other buzzwords. And we are trying to do that because we are trying to protect people from typical mathematical problems which are known that are not safe for quantum computers. So integer factorization, discrete algorithm problem, and elliptic curve. Because it's known that most probably all common algorithms will be easily breakable when quantum computer will come. So why we added? So NIST finalized FIPS 203, FIPS 204, FIPS 205, which is MLChem, MLDSA, SLHDSA, really earlier than expected. They finalized that, I think it was August last year. Immediately after, most of the browser vendors switched to MLChem support. And you can see on the chart below how it was looking. Here we decided that we will do post-quantum, and in that time, it not because of us, but they started immediately somehow implementing MLChem in browsers. So we decided after 3.4 release that we need to do something with that, and simply we want to protect our users and give them chance to use it. And as we have in our mission that is security and privacy, there was no other option than add it. There are also other things which are not for users, so industry demand, when government is forced to use it, and also customers which are communicating with government and many other people. So that is another reason, long-term signatures, because you need to sign something for longer time, like CAs or firmware or something, and keys, which needs to be secure, which will finally do that, again, another buzzword, record now, decrypt later. So we want to protect that. So PQC approaches, most probably you know about them. Lattice-based, hash-based, code-based, multivariate polynomial cryptography, and isogeny-based. For now, the three approved are lattice-based and hash-based. Nothing else yet. There is ongoing work. Most probably we will see other algorithms soon. The next one, almost approved, is Falcon, which is again lattice-based. So MLChem is for keys. It's simply FIPS 203. It should be quantum safe, so it secures your keys itself. Then if you are interested about the speed of MLChem, you can see it on fourth, fifth, and sixth line. Because we have OpenSSL speed, OpenSSL application, most probably you know, we have parameter speed, and you can do -chem algorithms, and it will, in a long while, generate this output. And you can see that RSA for key generations is really slow according to MLChem, and encapsulation and decapsulation is same or faster than RSA, which is typically used. This one is used in TLS, so you can see that is really fast. Also, 14,000 encapsulations per second is not bad. Next one, what we added was module lattice-based digital signatures, simply MLDSA, which is used for keys and digital signing. We support, because we doesn't support hash-based, but we support external mu, but only through API. So right now there is a limitation to get signature, and that limitation is your memory. Because we need to load everything into memory, then sign it, and that export it from the memory. So if you need bigger algorithms, use our API, or bigger files, use our API. Another is SLHDSA. It's similar to MLDSA. It is slower, but is considered as a safer, because if MLDSA will be broken, this most probably will not be. But we still take it as a backup solution because it's slower, which is usual problem. So again, some recap: FIPS 203 MLChem, FIPS 204 MLDSA, and FIPS 205 SLHDSA. We don't have hash variants. Reason for that is quite clear. There is no agreed what will be the key output format. So we can't add it because we don't know how to present it for now. There is discussion in IETF. If it will happen soon or not, hard to say. Most probably after July IETF Madrid workshop, maybe. So by default, 3.5 is post-quantum safe and supports by default post-quantum algorithms. So if you use OpenSSL, it will by default use MLChem for key shares and MLDSA. Specifically for TLS, MLChem will be used. MLDSA like CA and long-term, SLHDSA, again, available as a backup. And MLChem can be used, and identity certificates and other things which are related to keys. And we have new chem and signature APIs available. We will see them in a short while. So hands-on, what we will do, we will try to create CA using MLDSA through command line. We will create an entity certificate, and we will create MLChem key pair and certificate using CMS. So hopefully you are aware about OpenSSL. So first line will generate private key using MLDSA 65, and output will be MLDSA CA key. Then we will create certificate using MLDSA and using the key. So we have, I hope that you are familiar with @text extensions. So @extension for certificates that you can sign CA. Most probably you are, because everyone is using that. Then we will generate MLDSA private key. We will export from private key, we will export public key. We will create, that is another way how to create certificate, because you can create certificate directly, or you can use CSR, certificate signing request. So this will, the third block will generate certificate signing request. And last one, you will use certificate signing request to create the certificate itself. So it's the flow. Then we will create MLChem private key. It's easy. You can see that OpenSSL Gen key algorithm is same, and what is changed is only MLChem or MLDSA, nothing else. It's easy. So easy to use. And if you need RSA, you will just replace MLChem and MLDSA with RSA, and you will get exactly same. So we will again, from private key, we will get public key. And there is another way how to generate certificate without CSR. So you can force public key, which is normally stored in CSR, and you can create certificate. It's quite easy, I think. Maybe not, the syntax is not easy, but we have documentation for that. And you can take this presentation and just copy-paste, easy. So why we did all the things? Again, you can use our S server and S client. So we generated certificate, we generated key. So we started certificate with generated certificate and certificate key. We started server, and we used client, and we had to use CA file, which means because we didn't generate any common CA, so we had to specify that we want to use that specific CA. We did it for MLDSA EE.example, so we had to specify that we'll match it. And we specified the domain again that we will verify. And you can see that connection was established using MLDSA as a signature type, and was negotiated TLS 1.3 group, that horrible long name represent MLChem. So MLChem key was used. That's nice, né? Yeah? So, and it's easy. So there is nothing hard about post-quantum in OpenSSL. So next thing, what is interesting for people, and someone asked me on the booth, how to do object signing. We go through that. We will reuse the certificate which we created before, and you can see that we can select some file or tar.gz or something, and we say that MLDSA certificate will be the one who will sign it, and we will sign it with a key. And output will be some .dat file, which is mentioned on the first line. In the header is written detached, which means we will create signature which will not contain the data. There is another way that you can create a signature which will contain the data. So it will be much, much bigger, of course. This is like small file when you can sign some binary and deliver it separately. And you can use it just for control if that file was delivered correctly, for example, or not modified on a way. The second part is how to verify. So we will use exactly same certificate and CA file, yeah, because we need to say through which CA was signed. And this is special parameter minus signer, who.pem, which will give us information who signed it, what key was signing it. And that will be available on next slide. So here we can see that file was not modified. The signature is same. So it can be used easily on any transfer anywhere that file was really not modified. And then we can use X509. We can use in who.pem, which we exported on previous step, and just print it, who did it? And we can see that was MLDSA EE example key, and that are dates which are set for the key. Because I think if you will have a look on the slides, we generated key which was valid for 90 days. So we are lucky. We have 8 more days to be valid. Then I have to change presentation. So now we will cover the part using the code. If you are not a developer, it can be tricky, but I think it's again, it repeats similar way like CLI. This is what we are trying to cover. We have Alice and Bob. Sorry for the name, it's just common thingy what we are using. We will generate key. We will have public key. Then Bob will generate cipher text using the public key and send it to Alice. This is, I think, typical client-server scenario when you have server which receives public key, generates ciphertext, and that client can decode it, decapsulate, and get the ciphertext, which is finally the key which will be used for encryption of the connection. We will not do any encryption of the connection. We will just do the key generation, encapsulation, and decapsulation. So we need to define some variables. If you are interested, I can send you a whole file which contains the working part. Just text me on LinkedIn or whatever channel you will find. So these are mandatory to create because simply we need them. OpenSSL use EVP-PK, which is EVP-PK is for public and private key API. First line will try to get like query keygen using MLChem algorithm. We use MLChem 6768, which is considered as a medium security and is used by default as on TLS. So we get the key. We need to get the length of the key. It's a bit tricky in OpenSSL. You can see that pub is null, and when the parameter is null, we return the size. We return the public key, and then we return the size. So usually you will use, it's maybe not common scenario, but in many cases you will see nulls are used, which forces OpenSSL to generate values. Because if you will give the value, it will not generate, it will use the value. So here we generated the key, which is key A parameter, and that contains the key, which is defined as a EVPP key here on the, and then we will use key B for key B is for key Bob, yeah, Bob's key. So we will again define the algorithm. We will get the context from the name. it's always that you need to get the context with null parameters and algorithms, so you will get the context which will finally be used. Then we will generate context. We get the context for that specific algorithm. We init the context. We generate public key for Bob. Yeah. We try to generate, that will return something. Then we try to load it into key Bob, which we got, which is the public key. And we have a len, and then we free that. So Bob already loaded the key, so we have it. So we will do encapsulation. Again, as we use null parameter in many places, like on second line, we initialize that. On the third line, you can see encapsulate twice usually. That first one with null parameter, which will return the content length, what will be used, and we need to allocate memory for that. Otherwise, we can't store it. So first one is with null parameters, so we get the length, and we allocate the memory, and then we do encapsulation again, but we set the parameters instead of null. You see that CT is cybertext with some specific late, and shared secret for Bob and shared secret Bob length, and simply we will encapsulate that. And all that variables will be populated as a back reference. So, and you can see on a picture where we are. So Alice got the shared secret or the ciphertext and needs to get the shared secret. So it's again similar. Instead of encapsulate, we will call decapsulate. And it's same. Again, we will decapsulate some context. We will call it with null parameters, so we will get the sizes. Then we allocate the memory, and then we do decapsulation. And that's all. So that code is really not long to do that. And then you can easily generate a file and use it. Oh, I pressed something wrong. Okay. So sign and verify. Again, it will be really similar. We define some parameters. In this case, because we will do signatures, we need to use MLDSA or SLHDSA. We define something, and we will use the previously generated PEM file. So if you will generate it manually, you can easily load it. So we have some private key. We will load it with PEM read private key. So we will decode it, and we will have it. And then we will verify. The last line is really nice, that you can verify that your loaded key is MLDSA key. So it will fail if it's not. We will again define parameters like message, signature, message len, and other things. And last line of the definition, also params, you most probably will have something there. This is default, which is loaded from OpenSSL config. So if you will not define anything, OpenSSL config on your system will be loaded. So if you need specific things, you have to configure that either in configuration or specify here. So again, it's very similar. We will do the context for the key. We will do signature fetch. So we will get algorithm itself, because OpenSSL uses providers. I don't know if you are familiar with the concept. We have providers, and you can easily, it's like hash map, and you will load it and get all the things what you need, because we provide many of the signature algorithms, many of the CAMs and everything. And via that, you can easily load what you need. Then Again, we will do init to get context. Then we will do sign, again with null parameters, so we will get the length. We will define the memory, and we will sign it. So we have it signed, and again, Bob will load public key, and we'll do similar thing like Alice did. So we'll load the key, we'll read public key, it will check that public key is of that algorithm, because otherwise it doesn't make sense. Then we'll load public key, we will again fetch signature algorithm, and then is key EVPP key verify message in it. So it will load the message, will load the algorithm, and will load the context, which is finally the public key, and will verify on the last line. So, and that's all. It was verified. So what we added as a short summary, we added into OpenSSL MLChem, MLDS, SLHDS. Oh, sorry. We have added hybrid key agreement in TLS, which is the long name. We support 2 of them. This one and the previous one was mentioned on the previous one, starting with sec. And the difference between them is that this one is commonly used, and that sec one is FIPS version of this. We try to prepare our customers to be post-quantum ready. And we believe, because we are receiving quite a lot of questions about how to integrate, what to do, how to upgrade to post-quantum, it's easy with OpenSSL. If you are using OpenSSL free, you just upgrade, and you have algorithm available. You don't have to do anything else. Because our API in whole version 3.x is compatible. That applies also to FIPS module, what we have. The FIPS 3.2.1 validated 140-3 you can use in OpenSSL 3.5, 3.4, 3.3, 3.0. It will always work. Same thing will happen once we will get the certification for 3.5, which we already applied. It will be again applicable for any version 3. something, and most probably even further. We will see. We try to address record now, decrypt later, which is the common thing what everyone is asking for. And we know that especially US government is forcing everyone to use post-quantum until 2030. So everyone will have to upgrade to be post-quantum ready. So I've shown how to use it in CLI, how to use it in API. I think it's easy. It's not that hard. Just download OpenSSL. It's free. It's open source. Compile it. Use it. Easy. We covered TLS. You saw our server, how it's running in client. We covered CMS object signing. That was the part when we signed it. I think it was something from kernel. And how to do certificates. You can easily copy the command and you will have it. And simply, if you will have any questions about how to use it, we are here for that. Yeah? Use our communities, use our GitHub issues, send us email. Thank you. I was expecting.
So, I have a question regarding your plans on hybrid mechanisms. You currently implemented several key exchange hybrid mechanisms, which are hard-coded, the combinations, but do you plan to implement something more universal and not limited to key exchange, but also to signature? Thanks.
Good question. I think I have no answer.
Okay, please consider it as a Fisher request.
Yeah, let's say I have political answer for that, and especially for you, Dimitri, because you are part of our technical advisory committee. You can suggest that and drive that. I will, no doubt. That's perfect, because I know that, I don't know if you are aware, but we changed our governance. We switched foundation and corporation into two, not subsidiary companies, but sister companies. And each foundation and corporation has back and tech, which stays for Business Advisory Committee and Technical Advisory Committee. Anyone can join, representing that specific community, and everyone can make a difference. Yeah, so it's really important. If you have any idea what can be implemented, go to openssl-communities.org and help us. We need to hear bad stories. Yeah, what's wrong, what doesn't work, what you don't like. Because the good stories is nice to hear, but it will not change anything. So that is the point. If you are using OpenSSL, you have any idea what should be added, help us. Any questions? Okay, so since I don't see any more questions, thank you so much for this. Thank you.